Okay, welcome to the week 3 homework demonstration. We're going to go through a couple homework pieces in this one. We're going to look at some well-formed formulas. We're going to look at some symbolizing, and then we're also going to check out some truth tables. So let's go ahead and begin. All right, first, is it a well-formed formula? So I picked out two from the homework. These are on page 299, I think. So number one, got if A, then B, then C. And then number 7, we've got O, then not P, then R. So let's take a look at the first one first. So as you see here, we've got if A, then B, then C. And normally you'd think, well, this would probably be okay, right? If A, then B, and then C, if B, then C. The problem is that this is a ambiguous formulation. You don't know if it's if A, then B, then C, or if A, then B and C, right? There should be either a parenthesis here, an open parenthesis here, or a closed parenthesis here. There isn't any rule that lets you have terms like this. So this one is not a well-formed formula, a whiff. The second one here, number 7, a little more straightforward. We've got if O, then not P, then R, close, right? There's nothing wrong with this one. We've got each letter is by itself, or if it's in a if it's connected with one of these operators, it has parenthesis around it. There's no ambiguity. We know that this not applies to both this entire statement right here. This is just fine. This is a well-formed formula. So basically, if it follows all those rules that are listed in the textbook, capital letters, all that stuff, then it's fine. If it breaks any of those rules, any of them at all, even just one, then it's not a WFF. So follows the rules, whiff, doesn't follow the rules, not a whiff. All right, let's take a look at some symbolizing. So I picked out two homework statements here for us to try out. The first one is the statement, if humans are rational, then they are not animals, is false. And we've got R being humans are rational, A, humans are animals. And then our second one is, given that Linda is both smart and diligent, she will do well. But Linda is not diligent. And then we've got our statements here, S, Linda is smart, D, Linda is diligent, and then W, Linda will do well. So let's try it out here. Let's do the first one first. And so this is the way I symbolized it. So the way the statement looks here is, the statement, if humans are rational, then they are not animals, is false. So we're about to say, like, the thing that's about to follow is false. So I have this not here, and then we have a parenthesis opening for the statement that we're saying is false. And the statement is, if humans are rational, right, humans are rational is R, right, then they are not, then they are not animals, right? So humans are animals. So we've got, it is not the case that if humans are rational, then it is not the case that humans are animals. So in English, we would say this as, if humans are rational, then they're not animals. And here we go. Here it is symbolized. Let's do the same thing with number 11 here. Given that Linda is both smart and diligent, she will do well, but Linda is not diligent. So this one's a little bit more complicated. So given that Linda is both smart and diligent, then she will do well. All right, so this is one statement here. There's one part of it. Given that Linda is both smart and diligent, then she'll do well. But, now here's the funny thing about symbolizing these things. But and mean the same thing, right? It's this is true, and then also this other thing is true, right? So and but mean the same thing in logic. In fact, if you think about it, but is just and, but with a negative feeling. Like, this is true, and this other thing is true, but it's sad that this other thing is true. But and mean the same thing, really. So if you take a look, then we've got Linda is smart. Given that, if Linda is smart and Linda is diligent, then she'll do well. But, or and, same thing, it is not true that Linda is diligent. All right, so this is how that one would be symbolized. Not too bad. Okay, let's try some truth tables. Now, we don't have to worry about symbolizing for these. We've just got some truth tables. I picked out 2 of them just to demonstrate how these are done. We'll do each one of them independently. The first one is really simple. F then G, and F, therefore G. So here's how we would do it. All right, let's take a look at this first one, number 2. So the first thing we have to do is put enough rows here to get all of the combinations of true and false for our components. Our component pieces here are F, the proposition F, and the proposition G. We're going to need 4 lines to represent them being true and false. So we've got, in this case, we've got true, true, false, false, and then true, false, true, false. So if we had a third line, it would be true, 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 false, 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 right? So you do true, false, you alternate one after the other, then you do them in sets of 2, then sets of 4, then sets of 8. These can get really big if you have a lot of letters, a lot of symbols to work with. So once we've got all the combinations, and this is all of them, right? This is the only 4 combinations of true and false for these 2 statements, F and G. Either they're both true, they're both false, one of them's true, one of them's false, or the other one's true and the other one's false. All right, so now that we have all the combinations here for F and G, let's see how they work with these actual premises, because premise number 1 is not F or G, it is if F then G. Well, if F and G are both true, then if F then G is true. However, if F is true and G is false, then it is false that if F then G. That would be false. If F is false and G is true, right, according to our rule about how these conditionals work, then that's true. The statement as a whole is true. And then if they're both false, then the statement as a whole is true. And then this second premise is just F being true. So obviously true, true, and then here false, false. So easy. All right, so the conclusion, again, true, false, right? They just copy straight over because it's just G. True, false. Now, for an argument to be valid, there would have to be no instances where you have a false conclusion and true premises. Right? So all we have to do is look for the false parts of the conclusion here, these 2, and look to see if those have true premises. Well, here's one. And notice we don't have true premises. One of them's true, but the other one's false. Right? So that one doesn't matter. And then here's another one. It's false. False conclusion. Now, are the premises both true? And they're not. Right? Only one's true, the other one's false. So there are no instances where you have true premises and a false conclusion. Never happens. Which means that this argument right here is valid. Proven it valid. There are no combinations of true and false where you get true premises and a false conclusion. So this one's valid. All right, let's take a look at the next one. Number 14, you notice we have 3 different letters to work with. Right? So remember that rule for how we figure out all of the true false values. You notice we do by 1, true false, true false, true false, true false. And then by 2, true true, false false, true true, false false. And then by 4, true 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 true, false 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 false. And this is all the combinations, right? You don't have to go through it and look like, well, did I get all of them? You know, did I forget maybe one false, true, false? It's like, no, it's right here. See, you have included every single possible one. All right, now here's our first statement. If A, then, and then we've got in parenthesis, B, then C. Now remember, if the antecedent here is false, then the statement as a whole is still true. So you notice for A, here are the ones that are false. All right, these ones right here, these bottom 4. So these are just automatically true. You just fill them in. I don't even have to go through and look at the rest of this. Since the antecedent for the statement as a whole is false, then the statement as a whole is true. So then I can just put true right here. Now, same thing goes for this next part. Is if A, then this part, this section here. And this, if B is false, then this as a whole is going to be true. Right? So then you would get if true, then true, because we've already excluded all the false ones. Now we're just looking at the ones where A is true. And so for these, it matters whether or not if B, then C is true. And B in this case, if it is false, then this statement as a whole is true. rendering the whole statement is true. So this part right here would be true as long as B is false. So let's take all the ones where B is false. That's this one and this one, and we'll go ahead and make those true as well. All right, now we're getting somewhere. We're down to the last two. So for this first one, true, 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 right? If A is true, then B is true, then C is true. That one's true. That's fine. But this one, the second one, is where we get into trouble. If A is true, then B, then C, and C is false while B is true, right? Then this part would be false, which would make this, if A, then B, then C, this part would be false as well. So that means for the combinations of T, T, and F, we have a false conclusion, a false statement as a whole. Okay, so that's the premise. Now the conclusion, we go through much the same thing. You notice whenever you have a conditional like this, if the antecedent of the conditional is false, then the statement as a whole is true. So these bottom four, right, where the antecedent is false, those just become, the statement as a whole is true. Easy, no problem. And again, this first one, true, 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 that's fine. This is true. You notice though that the conclusion has more false combinations than the premises do. So in this case, since both of these have to be true for the statement as a whole to be true, any combination, these three here, where, okay, one's true, the other one's false, this first one's false, second one's true, or they're both false, that makes this statement as a whole false. So if you have true, then false, then this statement, the whole statement, is then false. So that makes these three combinations here false as well. All right, so now we're going to take a look to see if it's valid. And the way to do that is you just look and see, are there any combinations where the conclusion is false and the premises are true? And there's actually two of them right here, these two. We have true premises and a false conclusion, which makes this argument form, this one right here, invalid. We've proved it using a truth table. All right, I hope this helps. Remember, use the homework forum if you have any questions or if you get stuck on any of them. Sometimes one of your fellow students will be able to figure it out and help. Other times your professor will swoop in. This is how you do the homework for this module.